One of the other things that we can use this definition of continuity for is sometimes we can take a look at a function that's not continuous, and we can actually use this definition to make the function continuous. So let's consider the rational function f of x equal to x squared plus 3x minus 40 divided by x squared minus 2x minus 15. And the value that I'm going to be really interested in is the value x equals 5. If you take a look at what happens at x equals 5, the denominator, 5 squared is 25, minus that becomes 10, minus 15, the denominator is 0. So f of 5 is undefined. And because it's undefined, that means that I have a discontinuity. We talked in the previous topic about figuring out which type of discontinuity, but the denominator, if I substitute 5 in, I get 0. It is not continuous at x equals 5. But the question that could be asked is, what would f of 5 have to be defined as in order to make f of x continuous at x equals 5. So again, I have a function that's not continuous at 5, but maybe I wanted to kind of build a piecewise function where I said it's this function for all x not equal to 5, and then I let it equal a specific value for x is equal to 5. Well, in order to make this function continuous at x equals 5, to be continuous at x equals 5, then the following statement would have to be true, that f of 5 would have to equal whatever the limit as x approaches 5 of f of x was. So if this exists and is equal to some value, then the answer to this question right here would be that same value. That's what I would need to define f of 5 as to make the function continuous. And so what I'm looking for, really the answer to this question, was whatever the value I get for the limit as x approaches 5 of x squared plus 3x minus 40 over x squared minus 2x minus 15. And if I look at evaluating this limit, we already know the denominator goes to 0. The numerator, that becomes 25 plus 15 minus 40, it also goes to 0. So I get that indeterminate form, which means I need to do something. And as you can probably tell, that something is to factor both the numerator and the denominator. The numerator factors as x plus 8 times x minus 5. And the denominator factors as x plus 3 times x minus 5. I get that common factor of x minus 5 to divide out. So I'm really looking for the limit as x approaches 5 of x plus 8 over x plus 3. Which we can now again try direct substitution and say that's 5 plus 8 over 5 plus 3, which is 13 over 8. So because the limit as x approaches 5 of the function is equal to 13 over 8, then in order to be continuous at x equals 5, f of 5 must equal that same value, 13 over 8. So really the answer to this question, all we really had to do was figure out what the limit as x approaches 5 was, and then our definition of continuity said, okay, if you want to make it continuous, then that's also what f of 5 has to equal, and so the answer really came down to us just having to find the limit as x approaches 5 of that function.